Welcome back, guys. Today we're going to be looking at topic 5.3, which is solving systems of equations using substitution. Now, this is one of two algebraic methods that we're going to be using in this unit. Now, with substitution, the ultimate goal is to sub one equation into the other equation and use those to find our missing variables. Now we have two examples here. We've got two equations here. We've got 3x plus y equals 3 and 7x minus 2y equals 20. Now when I'm working with my algebraic methods, often one of the first things I'll do is number my equations. Now for the first couple examples here, I'm going to use a flow chart to show you how to solve using substitution. And then as we work through the other examples, I'm going to just work through the questions. Now, when you're going through this video today, I have 6 different examples. Feel free to use as many or as little as you need. But again, I would suggest maybe as you get further into the video that you pause the video, try the question, and then come back and check your answers. All right, so using this flowchart, the first thing we want to do is we want to look at our equations and we want to ask ourselves, is there a variable isolated? Now, in this case, there is no isolated variable, so that means no, there's no isolated variable. So we're going to go to this side of the chart here. So the first step we have then is to isolate a variable. We're going to choose the variable that's easiest to isolate. So we look at our two equations here and we ask which one is easier to manipulate and solve for one variable. And it doesn't matter whether we're solving for x or y, we just want to rearrange. Now a tip that you can use is to look for the variables with coefficients of plus or minus 1. So in that case, that's going to be this one right here, 3x plus y equals 3. Once we know which equation we want to manipulate, then we can write it down here. So 3x plus y equals 3. And we're going to rearrange to solve for a variable. Well, in this case, the y is what we're going to manipulate and solve for. So to solve for y, we're going to subtract 3x from both sides. And that's going to give me y equals 3 minus 3x, or you can write it as negative 3x plus 3. It doesn't matter which way we write that. Now, once we have that equation, then we move on to step 2. And so it says to substitute the expression for the isolated variable into the other equation. So we have this equation, y equals negative 3x plus 3. And we have our other equation that we haven't worked yet with, and that's 7x minus 2y equals 20. Now we call this substitution because we're ultimately going to substitute one equation into the other. So we're going to take this negative 3x plus 3 and we're going to substitute it in for y. So we're literally going to take and plug and play, replace one with the other. So we have 7x minus 2, and where we see the y, we're going to write negative 3x plus 3 equals 20. Now, from here on out, all of the hard work's done. We're just going to multiply out our equations, solve for our variables, and do a little bit more substitution. The hardest step is doing that movement right there from negative 3x plus 3 into the y position. So just picture this like substitution in volleyball. I've got a player that's on the court. I need to put a new player in, so I just swap them out. All right, so we've got 7x. Negative 2 times negative 3x is positive 6x. And negative 2, so remember we're distributing these through, so negative 2 times negative 3x and negative 2 times positive 3. We have 7x plus 6x, and then negative 2 times positive 3 is negative 6 equals 20. We're going to simplify. 7x plus 6x is 13x minus 6 equals 20. We want x by itself, so we're going to add 6 to both sides. And that gives me 13x equals 26. To get x by itself, we're going to divide by 13. And that gives me x equals 2. Now, there's obviously lots of opportunities for making mistakes just with algebra, so it's important that you check your math as you go. But ultimately, the difficult part of the new concept here is to just do that substitution. Now, once we have x equals 2, we need to figure out what y is. So we're going to move to step 3 here, and step 3 says to substitute the value for the variable from step 2 into the equation with an isolated variable. In other words, we're going to sub x into the equation that we haven't used yet. So our original equation that we had to manipulate, 3x plus y equals 3, and the x equals 2 are going to be combined. Now, you could have just as easily taken the negative 3x plus 3 and used that here. I like to work with the original questions as much as possible. So I'm going to take that x equals 2, and I'm going to substitute it in. It's time for a switch in volleyball. I'm going to substitute that in for x. All right. So rewriting this, I'm going to have 3 times 2. Now, when I do substitutions, I always try to use brackets. 3 times 2 plus y equals 3. 3 times 2 is 6, plus y equals 3. We're going to subtract 6 from both sides, and we have y equals negative 3. Now, to be a system of equations, these values have to work in both equations. So it's always important that as our last step, we verify our answers. So to verify, we're going to set up a left side, right side chart. And we have to do this twice because we have to make sure it works for both equations. All right, so for the first equation here, we have 3x plus y on the left-hand side, and we have 3 on the right-hand side. And for our second equation, we have 7x minus 2y and 20. So we're going to sub in what we know and see if they match. So we've got x being 2 and y being negative 3. So we're going to sub in 3 times 2 minus 3. 3 times 2 is 6, minus 3. 6 minus 3 is 3. These match. Checking the other equation, 7 times 2 minus 2 times negative 3 gives us 14 plus 6, which is 20. These also match. So since both equations match, we can write our answer down as 2, negative 3. So we write our solution often as a coordinate, just like when we were graphing. All right, let's take a look at the next example here. We have x equals 12 minus y, and x plus 3y equals 8. So again, when I'm doing these questions, I like to number my equations, probably more so when we're not using the flowchart. This will come into play. So again, we look at our equations and we ask ourselves, is there a variable isolated? Well, there already is. This one here has already been isolated for x. So we can go straight to step 2 and we can skip the manipulation. These are always nice because it's a little bit less work. All right, so we have x equals 12 minus y, and we have x plus 3y equals 8. So our first step is to do the substitution. We have 12 minus y, and we're going to replace, again, I like to think volleyball. I like to replace that player on the court. You can think basketball or baseball as well, but I think it's an easy visual if you're thinking about a swap or a substitution in sports. All right, so we're going to take that x and we're going to replace it with 12 minus y. So we're going to write 12 minus y. Again, I like to use brackets. Plus 3y equals 8. And then we're just going to simplify here. So we've got 12 minus y plus 3y equals 8. And that gives me 12 plus 2y equals 8. We want to get y by itself, so we're going to subtract 12 from both sides. That gives me 2y equals negative 4. We divide by 2 on both sides, and we have y equals negative 2. Now moving on to the next step here, we're going to substitute that negative 2 into the equation that we have not used yet. And so that's or I guess another way to think about that is the equation we haven't subbed into yet. So we've got x equals 12 minus y and y equals negative 2. And so we're going to take the negative 2 and we're going to put it in for the y. Now, be careful when we have a negative in front that you don't lose a negative as you're doing your substitution. So this is why brackets are important. So x equals 12 minus, in brackets, negative 2. And so the negatives are the most important reason to use brackets. And so if you get in the habit of using them all the time, then it won't be as challenging and you won't make as many mistakes. So 12 minus negative 2 is 12 plus 2. That's x equals 14. Again, we can't be done unless we've checked our work. So we're going to do a left side, right side verification here. And left side, right side. So for the first equation, we have x on the left and 12 minus y on the right. And for equation number 2, we have x plus 3y on the left and 8 on the right. So we're going to do our substitutions here. X is 14 and 12 minus, again, use those brackets, negative 2. 12 plus 2 is 14. For the second equation here, we've got x, which is 14, plus 3 times negative 2 becomes 14 minus 6, which is 8. This also works. So since both equations work, our final answer is 14 comma negative 2. Now it's important that as you're doing these, you make sure not to mix up your x's and y's because you might do everything right and then that little swap at the end would give you the wrong answer. All right, so that's one way to do this, is just to work through a flowchart, and for some people that visual will help. For the remaining examples, I'm just going to walk through the steps as we go. So all the way along the side, I'll kind of have the steps written off to the side. All right, so for our first example here, it says 2x plus y equals 4 and 3x plus 2y equals 3. In all cases, we're solving algebraically. So when I'm not using a flowchart, I would definitely start by labeling my equations. Again, the first step is to choose one of these equations to rearrange. So if we look here, there is nothing that's already rearranged to solve for a variable. But when I look at equation 1 and equation 2, I ask myself, which one looks easier to manipulate? And that's going to be number 1. And number 1 is going to be easier to manipulate because I can easily solve this for y. So this is going to be my third equation. And so rewriting this, I've got 2x plus y equals 4. And when I rearrange, I'm going to subtract 2x from both sides. And that gives me y equals 4 minus 2x, or negative 2x plus 4. It doesn't matter which way you write it. Both ways are accurate. Now, once we have that equation, we're going to sub it in. We're going to sub it in for the other equation. So we've already manipulated equation 1. So this negative 2x plus 4 is going to get subbed in for our y. So again, we're just swapping players. So writing this step out here, we're going to have 3x plus 2. But now instead of writing y, we're going to write negative 2x plus 4 equals 3. So we've got 3x distributing throughout. We're going to have 2 times negative 2x and 2 times 4. So we have 3x minus 4x plus 8 equals 3. And 3x minus 4x is negative x plus 8 equals 3. We can subtract 8 from both sides. And that gives me negative x equals negative 5. And dividing by 1 on both sides, that gives me x equals 5. Now that gives me one variable, so now I have to sub into my other equation. So the equation that I have not substituted into yet is the 2x plus y. So I've got 2x plus y equals 4, and we're going to take that 5 and we're going to put it in for x. So we've got 2 times 5 plus y equals 4. So 10 plus y equals 4. And subtracting 10 from both sides, we have y equals negative 6. Now, just like before, we need to verify our answers. And so if we're verifying algebraically, that's going to be using our left side, right side chart, but we can also verify graphically. So if in a question you're specifically told to verify algebraically, the expectation is that you're using the left side, right side chart. If you're told just to verify your answer, you can also do that graphically. So you can graph these on paper, or we can use our calculator. All right, so we're going to pull up the calculator here. and we're going to use our original equations. Now, as I'm entering these in, you're going to notice that I'm not going to have them completely written into y equals mx plus b form. I'm just going to do the manipulation as I would put it in my calculator if I was trying to do this quickly. So the first equation, I've got 2x plus y equals 4. So to get y by itself, I'm just going 4 minus 2x. So on my calculator, I'm writing 4 minus 2x. And the other equation, in order to get y by itself, I'm going to have to subtract 3x and then divide by 2. So this part has to be in brackets. I've got 3 and I'm going to subtract 3x, close my brackets, and then the next step would be to divide by 2. So I know that might not look the same way that we'd write it on paper, but it's a quick way to get it into my calculator. And it will still give me the same answer. So I've got my equations graphed, checking my answer, second calc intersect, enter, 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 and we've got 5 comma negative 6. So this is a valid answer. So I know that's my answer. All right, let's take a look at a few more examples here. So example number 2, we've got 2x minus 3y equals 12. Again, my first step is to label my equations, and this is again just my way of keeping myself organized. Being organized on paper is very, very important. So we've got, especially when we're doing this method here, we've got our 2 equations. We want to ask ourselves, has anything already been rearranged to solve or to be set equal to x equals or y equals? And it has been. Step number 2 here, we've got x equals 4y plus 1. So I could actually skip a step and go straight into my first substitution here. So I'm going to take this 4y plus 1 and I'm going to sub it in for x. So writing that out, that's going to be 2 times 4y plus 1 minus 3y equals 12. Multiplying that out using the distributive property, we're going to distribute the 2 through the brackets. That gives me 8y plus 2 minus 3y equals 12. So 8y minus 3y is 5y plus 2 equals 12. We're going to subtract 2 from both sides, and that gives me 5y equals 10. And dividing by 5 on both sides, we'll have y equals 2. Now, we've already subbed into equation 1, so the one left to sub into is equation 2. So we've got x equals 4y plus 1, and we're going to sub in the y equals 2 in for y. So we're going to have x equals 4 times 2 plus 1, x equals 8 plus 1, so x equals 9. Now, I'm writing out every step here. If I was doing this as my own question, or I was doing this just when I'm doing my homework, I would often jump from the 4 times 2 plus 1 straight to the 9. So I wouldn't expect to see this 8 plus 1 written there. So my answer then, again, written as a coordinate, be very careful to look at where your x and your y are. X is 9, y is 2. There's my answer, but again, we need to verify. So all of these remaining examples, I'm going to be verifying using my calculator. And so I'm going to go in and clear out my equations. And for these equations here, the first one, I've got 2x minus 3y equals 12. So to get y by itself, I'm going to have some brackets here. I'm going to have to go 12 minus 2x. And then I'm going to divide by negative 3. And my other question, to get y by itself, I'm going to have to take the x and subtract 1. And then divide by 4. So we're going to graph our equations. Based on what I see here, it looks like I'm probably on the right path here. So second calc 5, enter, enter, enter. And we have 9 comma 2. So that is my answer, and I know I've done it correctly. So this is verifying graphically. All right, next example here, we've got solve the following systems of equations using substitution. We've got example 1 and example 2. Looking at these equations, the first equation has already been rearranged to say x equals, so I can jump straight into my substitution. I'm going to take this 3y minus 1, and I'm going to sub it in for x. So 3y minus 1, I'm still going to use brackets. Again, that's just a habit I get into. 3y minus 1 plus 2y equals 9. So 3y plus 2y is 5y minus 1 minus 1, sorry. And so we got 5y minus 1 is 9. Now, to get y by itself, we're going to add 1 to both sides. And so we have 5y equals 10, divide by 5, and y equals 2. So that's my first variable. Now I've subbed into equation 2, but I have not subbed into equation 1. So that's the next one I'm going to work with. I've got x equals 3y minus 1. I'm going to sub the 2 in for the y. So I'm going to have x equals 3 times 2 minus 1. So x equals 6 minus 1, meaning x equals 5. So writing my answers there, I've got 5 being x and y being 2. So my answer is 5, 2, and then we'll check with our calculator. So to get, for the first equation, I've got x equals 3y minus 1. So to get y by itself, I'm going to go x plus 1, close my brackets, and divide by 3. And for the next example here, I'm going to have 9 take away x and divide by 2. Again, you could, if that's confusing for you, you can certainly write these out on paper as y equals, and then put them into your calculator in the same way. Second calc 5, and we have our solution as 5, 2. Now, if for some reason you got different answers, then you need to go back and check, did I do something wrong mathematically, or did I graph it wrong on my calculator? All right, so we're going to take a look at one more example here. And so our examples here, we've got negative 2x plus 3y equals 14. That's equation number 1. And then x plus 2y equals 7 is equation number 2. Now, looking at these equations, neither of them have been manipulated to isolate a variable. So our first step is to choose which one we're going to isolate. Now, if we look at the first one, we've got coefficients that are greater than 1 in front of both x and y. But if I look at equation number 2, x looks very easy to isolate. So that's the one I'm going to work with. Now, to get x by itself, I've got x plus 2y equals 7. To get x by itself, I'm just going to, to get x by itself, I'm just going to subtract 2y. So that gives me x equals 7 minus 2y. Now again, you could write that as negative 2y plus 7. You'll still get the same answer. So we've manipulated equation number 2, so we want to sub into the other equation. So we're going to take this 7 minus 2y, and we're going to substitute it in for the x in the first equation. So that would give us negative 2 times 7 minus 2y plus 3y equals 14. Using our distributive property, we'll distribute the negative 2 through the brackets. Remember, this is our stop sign right here. And so we have negative 14 plus 4y plus 3y equals 14. We're going to simplify both sides. So we've got negative 14 plus 7y equals 14. We'll add 14 to both sides. And that gives me 7y equals 28. Now to get y by itself, we're going to divide by 7 on both sides. And that gives me y equals 4. Now, quite commonly when I'm working with substitution, or I see students working substitution, the mistake, or the most common mistake we see, happens right down here. So we'll do everything right, do all the hard stuff right, and we'll get down here, we'll go 28 divided by 7, and we'll write the wrong answer. So just always make sure to check your math as you go. So we've got y equals 4. We've already subbed into equation 1, so now we're going to sub into equation 2. So equation 2 is x plus 2y equals 7. So we're going to substitute the y in, or the 4 in for the y. So we're going to have x plus 2 times 4 equals 7. So x plus 8 equals 7. Subtracting 8 from both sides, we have x equals negative 1. Again, we'll write out our variables here. X is negative 1, y is 4. Be careful not to mix those up. And then we're going to double check with our calculator. So for our calculator here, we've got our two equations. The first one, we've got negative 2x plus 3y equals 14. So to get y by ourselves, or by itself, the first thing we're going to do is take the 14 and add the 2x. Notice I'm keeping that part in brackets. And then we're left with the 3y. Well, to get y by itself, we're going to divide by 3. The other equation, we want y by itself. So we're going to start off by taking 7 and subtracting x. And then we're going to divide by 2. Now, all of these particular questions I've given you, they all fit on that standard 10 by 10 grid. We can certainly work with bigger equations as well, but this is a good starting point. So second calc intersect, enter, 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 and we have a solution of negative 1 comma 4. So we've done everything correctly. As you work through these questions, just follow those steps. Make sure that you keep your work really organized. Putting boxes around your answers as you go will help, but the neater and the more organized you can be, the less chance you have for making mistakes. So that's all I've got for you today, guys. Have a great day, and we'll see you soon.